All right, number one, identify the type of equation seen here. So y is equal to 200 times 1.5x. Remember, if the exponent is a variable, then it's automatically an exponential function. Number two, which of the following is the solution to the inequality seen here? So we want to solve by subtracting 3 on both sides. And then we're going to divide by 5. So x is greater than or equal to 1. That's going to be option A. 3. Given the equation 3x equals to 4 plus 5x, determine how many possible solutions exist. Okay, so let's go ahead and solve that equation. So I'm going to subtract 5x on both sides. And then divide by negative 2. So x is negative 2. And that's the solution, and that is the only solution. So this one has one real solution. Number 4, given the graph above, which of the following is true? Select all that apply. So just select all that apply. So make sure we check all the 4 answers. The domain goes from negative infinity to positive infinity. That is true. All right, it keeps going to the left and it keeps going to the right. The graph has one real root. So the root is where it crosses the x-axis, but it crosses 1, 2, 3 times. So it's not B, it's actually C. The graph has 3 real roots. And then there is a maximum at 1, negative 3. No, that's false. It's not a maximum. Number 5, we're going to solve for y. So 2x minus 3y equals 12. So this is basically a literal equation. We're solving for one of the variables. Our answer will be an equation. So first we subtract 2x because we want to get the y by itself. And then divide by negative 3. So y is equal to negative divided by negative turns positive. I'm going to leave it as a fraction since 3 cannot divide 2. And then 12 divided by negative 3 is negative 4. The answer is y equals 2 over 3x minus 4, which is option B. Number 6, which of the following statements are false? Select all that apply. False. Y is equal to x squared is an exponential function. That's false. It's actually a quadratic function. So that's one of our options. Y equals 2 to the x power is an exponential function. That's true. Okay, so that is not one of our options. Remember, we want only the false. Y is equal to 2 to the x is a quadratic function. That's the false one. Remember, that's an exponential, like in option B. D, a linear equation always has 2 real roots. Linear. So if you graph a line, doesn't matter how you graph it, it would only intercept the x-axis one time. Okay, so that's going to be false as well. All right, 7, 4 minus x over 2 is equal to 11. We're going to solve for x. So let me do it over here where I have more space. Okay, so to clear the fraction, first thing I'm going to do is multiply both sides by the denominator. That way these 2's over here go away. So You're left with 4 minus x is equal to 22. We could subtract 4 on both sides. You're left with negative x is equal to 18. And then to turn the x positive, you divide by negative 1. So x is equal to negative 18. That'll be option D. Number 8, identify the roots of the graph seen above. So here's a root, this is 0, comma 0, and this is 4, comma 0. Our answer is B. Number 9, determine if the graph below fits any of the following function descriptions. Okay, so we see this is not a line, this is a curve, and this is always increasing, so this is an exponential curve. That's going to be letter C, because remember, quadratic goes up and down. Exponential either always goes up or always goes down. Number 10, Andrea solving the equation below, which of the following is true? Okay, so let's see what Andrea did. Like she distributed. Negative 4 times 6 is negative 24. And negative 4 times negative y, that's actually positive 4y. So that's her mistake right there. Her step is in step 1. She forgot to multiply the negative times the negative. So in step 1. All right, solve for x. The absolute value of x is 2. Number 9, which numbers are 2 units away from 0? 2 and negative 2. So it's going to be B. Which of the following will represent the graph seen above? Okay, so from negative 2 to 5. Negative 2 is open, so that should be a parenthesis. 5 is closed, so that should be a bracket. So from negative 2 to 5 with a parenthesis and a bracket, that would be option C. Find the range of the graph seen below. Okay, this graph is complicated, but remember the range is from the lowest to the highest. Y values. Okay. The lowest to the highest. So what's the lowest y value that we see? See how the graph is the lowest, the graph goes here? That's 0. So it's from 0, and then the highest it goes is here. This is the highest graph goes. That's 4. So it's from 0 to 4. Okay, and they're both closed, right? This graph goes through those points. So it's closed. And so they're going to be brackets. So bracket, bracket from 0 to 4. It's going to be option B. 14. Sam was asked to solve the absolute value equation seen here. 2 times the absolute value of x minus 3 plus 4 is equals 10. Sam's work is seen in the chart below. Review Sam's work and then choose the statement that best describes Sam's work. Okay. So here's the original. And then Sam split the problem into 2. But remember, first you need to isolate the absolute value. So Sam did the mistake in step 1. Here's the way you should do it. Okay, you should first subtract 4 on both sides. And then divide by 2. and then split it. Okay, you split it once the absolute value is by itself. One's positive and one's negative. And then you add 3 to both sides. So if x is equal to 6, x is equal to 0. You see how the answers don't match up? One of them did, but the other one didn't. Okay, so the mistake was made in step number 1. Okay, solve the following inequality. Let me do that over here. We have more space. Okay, and I want the variable on the right side. You see how on the answers, the variable's on the left. The left side. So I'm going to subtract 3x from both sides first. And then I'm going to subtract 5 from both sides. And then I'm dividing by -2. And remember, when you divide by a negative number, you switch the inequality. So x is greater than -1. So please remember, when you divide by a negative number, you switch the inequality. Number 16, consider the inequality which of the following would not be a solution. Okay, so let's go ahead and solve this first. First, we're going to distribute. So 6n plus 60 is greater than 30. Then I'm going to subtract 60 on both sides. So 6n is greater than -30. And then divide by 6. So n is greater than -5. Okay, I think it's going to be easier if we see a graph of this. So at -5, it's going to be open. It's going to be to the right. So all the numbers greater than -5, like -4, -3, and so on and so on and so on. Okay, those are the solutions. Which of the following are not solutions? So if it's not a solution, it'll be any number over here on this side. So -7 is not a solution. It's on the left. -3 is, -4 is, -5 is not a solution because it's open. If it's an open circle, it's not part of it. If it's closed, it is. Okay, but this one's open. So if it's open, it's not part of the solution. 17. Which of the following graphs would be a solution of -3 minus 6 times 4x plus 6 is greater than -11, 111. Okay, let me copy it over here where I have more space. Okay, so first I'm going to add 3 to both sides. Okay, so -6 times 4x plus 6 is greater than -108. Okay, next I'm going to divide -108 by -6. We'll divide both sides by -6. So 4x plus 6. Now I need to switch to inequality since I'm dividing by -6. And this is now 18. Okay, and then I'm going to subtract 6 on both sides. And then divide by 4. So x is less than 3. So it's going to be open at 3 and to the left. So let's see. Find the range of the graph above. So range are all the possible y values, the lowest to highest. So this is the lowest y value. This is the highest y value. So it's from -4, it's closed, to 2, also closed. So that's option C. 19, determine how many solutions exist in the absolute value equation seen here. Okay, well, let's start solving it to see how many it has. So if I subtract 20 on both sides, and then I divide by 5, now we have the absolute value of x plus 3 is equal to -2. But remember, absolute value cannot be negative. Okay, absolute value is a distance. So this one is no solution. Cannot solve this one. 20. Tyler claims that all graphs are function. Which of the following refutes Tyler's claim? So a parabola, that's a function. Do you remember the parallel line test? The parallel line, I'm sorry, the vertical line test. Vertical lines only touch the graph once. Okay, so that is a function. Same thing for a line and an exponential function. Okay, if we draw a vertical line, it only touches it once. But a triangle, if you have a triangle, if your graph is a triangle, you see how it could touch it twice. So not all graphs are functions. So the one that refutes Tyler's claim is going to be option D. And then number 21, we're going to solve for B if A is equal to 1/2 BH. So first we need to get rid of the fraction by multiplying both sides by 2. So those 2's over there go away. So now we have 2A is equal to BH. I'm solving for B, so I want to divide both sides by H. So B is equal to 2A over H. And that's going to be option D.